Right, good afternoon, everyone. Thank you for joining this call. The numbers dialing in are still increasing, but I think we'll make a start. So this is one of the monthly presentations from the United Kingdom Post of the Society of American Military Engineers. And we're joining you from RAF Mildenhall in AFIMSC's building. So yeah, thanks to those who've joined us in person and also those dialing in. And we're really pleased and honoured to have Mick Bilney, who's our most well-travelled presenter, having joined us all the way from Colorado. I'll let him introduce himself in a minute, but he's got plenty of experience over 30 years from I think at least 4 or 5 continents, maybe even 6, for various US public military and public services. And he's, as you can see on the screen, which I hope is coming through fine for everyone, he's going to be presenting to us today on climate risk and resilience. Without further ado, I'll hand over to you, sir.
Thank you very much, Tom. As Tom mentioned, I work in asset management and climate risk and resilience. I have projects that I've worked on and managed all over the globe. And the case studies that we'll talk about today apply to locations in the US and around the globe. And I'll talk a little bit about some definitions for the topic that I'm talking about. And so let's move forward. When we talk about what resilience is, it's really important to recognize that the word actually began in terms of ecosystems. And C.S. Holling was an early environmentalist. And talked about the capacity of an ecosystem to be able to adapt to and recover from shocks or changes that were dramatic in terms of its operation. And the Department of Defense, as everyone knows, has really come to terms with the fact that climate change is can have drastic effects on mission. And there has been guidance from the Undersecretary of Defense and Acquisition, as you can see, going back to about 19, but there's actually there's a lot since then, but it involves consideration of vulnerabilities to master planning, management of natural resources, design and construction standards, utilities, and so forth. And case studies that you'll see here actually will talk about that. There's some key terms that are really important when one talks about resilience and climate change. Hazard is one, of course, resilience is another, and risk. And there are a variety of definitions available from the Department of Defense, as well as the United States Air Force, the Army, the Navy. Sometimes those definitions vary a little bit, but what's really important is that organizations, when they take on looking at resilience, perhaps develop an approach to it or actually a resilience program, that they have a shared understanding of what the terms are that they're using and what the definitions are. In the case of at least one of the case studies I'll go over, we talk about natural hazards, and there are reasons for that. And I'll get to those in just a minute, but the climate and severe weather components you can see are common, and they're understood in terms of wind, water stress, heat stress, flooding, and so forth. And then the natural hazards that are part of the Department of Defense case involve earthquake, tsunami, landslide, and even most recently volcano. Also wildfire, brush fires, urban fires. Those are similar terms for this. We experienced that where I'm from, out in Colorado, at least up in Boulder County in 21, the Florida Panhandle in 21, in Australia last year and in Germany last year, and I think to some degree this year. And right now, the Isle of Rhodes is having some terrific fires that have affected that location. So they are becoming more predominant. And of course, everyone recognizes what's going on or is aware of what's going on in the US and elsewhere around the globe with the rising heat this summer, having been reportedly the hottest heat that the Earth has ever has experienced, at least in the last 100,000 years. The reason that we look at the combination in my work of climate, severe weather, and natural hazards, Hades really, when back in 21, they had a 7.2 magnitude earthquake. And then several days later, after the earthquake collapsed thousands of homes and disrupted roads, bridges, making them impossible, came Hurricane Grace with heavy rains, mudslides, and so forth. And so what happens is there's a negative synergistic effect between natural hazards of the ones that I showed a bit ago and climate and severe weather. And those can happen basically any time. The first case study that I'll mention is a hardening analysis, engineering analysis of a mission critical location that we did some time ago, where we focused on mission critical and enabling infrastructure to look at what was necessary to improve the resilience of the facility and to make it more resistant to a variety of different hazards, not only climate, but also, as you can imagine, the effects of enemy actions that were potentially there. There was some dramatic costs that we identified and so forth. The real important component is that the total project cost that we estimated to fix this particular vulnerable location was $360 million. The message there is when you wait to when you have to retrofit a facility to adapt to whether it's climate effects or natural hazards or both, it's far more expensive than if you design that type of resilience into the initial designs of the facility. And unfortunately, the area is having to retrofit and redesign. The next case study, the National Oceanic Atmospheric Administration, or NOAA, we did a risk analysis of over 3,200 properties around the US. Our scope was to identify the top 10. And what we found out was that the marginal differences in the data in the way that we scored, rated, and ranked the properties didn't give much value to identifying only the top 10. Actually, what NOAA had at that time was around 40 to 44 facilities that were the same or with very little difference between the 10 and the 40 in terms of their risk to climate change. So whenever anyone tells you that they want to identify the most at-risk asset, the top 2, the top 3, the top 5, the top whatever, you need to be cautious about how you approach that, because chances are your assets, your facilities are much more similar in their risk than they are disparate. And so from that project, we also conducted on-site site-specific analysis and identified a variety of different components related to single points of failure, as well as adaptation and resilience plans. And we were able to develop rough order of magnitude cost estimates for what it would take to address those. One of the single points of failure at one of the facilities happened to be a single road in and that was the same road that they needed when they needed to escape the facility. And that road particularly flooded every time there was a hurricane or a storm surge event, leaving whoever was there at the mercy of the wind and the water. So the next one was had to do with 2 Army bases where we looked at particularly flood risk in this case, both riverine as well as pluvial, meaning the water that would end up flooding the facility during severe rainstorms, which from the time the facilities were first developed continued to increase, at least in the case of one of them, over time. What we found there was that despite the thinking on the installation that it was coming from the rivers and so forth, and that was what was flooding it, it actually was the pluvial flooding from the severe rainstorms that the stormwater management system, because of years of deferred maintenance and lack of attention or understanding that it was a key asset for the facility, couldn't handle the volumes of water. And so the flooding on the base would frequently inundate mission critical areas to the point to where they could not execute their mission. And so our job was ultimately to identify these kinds of things and to recommend adaptation actions that could be done, whether a road or a bridge particularly needed to be elevated, or a bridge needed to be moved, or in this case, the stormwater management system needed to be addressed. And we take a risk-based approach to both climate and natural hazard vulnerability for these reasons, so that scarce resources can be allocated to mission critical assets. And that's a key part of what we do, is identify what's mission critical. And I'll show you more about that in a minute, as well as to defend the resource allocation decisions that are made at a installation level upward into upward management or the chain of command. And so that the installation can buy down the most risk with the least amount of investment, and then communicate why those decisions are made, and so forth. And it's really important to focus on asset and mission criticality, because if critical assets fail, they have a highly negative effect on the mission itself. And so the greater that negative effect, the greater the criticality. And we look at that in terms of the likelihood and severity and the risk to the mission from the assets and the infrastructure at the facilities. The resilience risk analysis that we conduct and have conducted in these case studies is based on certain principles, that it be systematic, be straightforward, that you can explain it. It's scalable. If you've already done some of the key important things up front, like an asset inventory, and you're confident you know where your assets are at and so forth, that you can do other parts of it, and that it's also simple in its effect. The systematic risk-based facility and asset natural hazard risk analysis approach that we take looks at the structures, the equipment, the asset systems, supply chain logistics. I'm going to have a little bit more to say about that in a second here, and the security of the supply chain for the parts, materials, energy, water, waste, that kind of thing, communications, transportation, and personnel. And what we look for is an accurate asset inventory. We identify what the threats are, vulnerabilities, the risk, and then the components of resilience. For an inventory, that covers vertical and horizontal assets, and so that we know what's where and what the condition and criticality is, and what the expected levels of service are. The threats cover climate change, severe weather, natural hazards, as I've mentioned, as well as the data that's necessary to be able to identify those components and how detectable the threats are. Vulnerability includes what the exposures are, the sensitivity of the assets and the infrastructure to them, and what the adaptive capacity is, not only of the installation in terms of the assets, but also the folks who live and work there, and in setting objectives and targets to reduce that vulnerability. We look for the effect of uncertainty on objectives in looking at the risk, the likelihood, severity, consequences, those common elements of calculating risk, and what needs to be done to control and reduce the risk, and the single points of failure. When we get to resilience, there are components of redundancy, robustness. These are also words that you'll see when I get to looking at a current Air Force example. The resourcefulness, response in terms of time and capability, and the resources available for that, as well as recovery. And in other words, metrics for how long and how much it costs to return to what level of mission capability is acceptable to upper command. The reason that you look at supply chain, and this is something that, of course, has become more recognizable since COVID and all the supply chain problems that every organization, whether they're military, civilian, or private sector, in terms of where it's at, how secure it is, how stable it is it redundancy? Do you have more than one line of supply for any one particular material, particularly those that are mission critical? Determining whether just in time is really viable for whether it's military or civilian operations, or there needs to be some approach that identifies sufficient supply on hand and in the pipeline as well, so that you know what's coming and on the way. And also, one thing I pointed out over the last several years is it's really important to identify, when you look at your supply chain, what the competitive nature might be for the supplies that you do need, that you do order. And that goes all the way from energy and water to asset assemblies and systems as well, whether it's filters, whether it's fuel, doesn't matter. There is competition that will come when bad things happen. And that also you need to look beyond the fence line, out into the local community, the region, country, global, and whether or not your supplies come from the US or whether they come from some other country. And if they do come from outside the US, regardless of that, how stable and secure are they? So here's where we did an assessment for the US Department of State for their whole portfolio of locations, 294 of them in 189 countries around the globe. And you can see that the Department of State has quite a bit of space, and the value of their assets is really significant. They're really proximate to severe historical natural disasters, from earthquakes to floods, destructive landslides, to tsunamis. And those things have either happened at or near the diplomatic posts. What we started out with was looking at screening of their portfolio to these natural hazards. What you see here: coastal flooding, riverine, tsunami, earthquake, landslide, wind, extreme heat, and water stress. And it's one of the interesting lessons that I learned is don't presume that everybody is most vulnerable to severe wind or to storm surge and things. We've found out some interesting things in terms of heat stress and water stress that actually have emerged over the last several months around the globe. We started out, the Department of State has a climate security and resilience dashboard where they have hazard exposures for their posts for the natural hazards that I mentioned. And we looked at them not only in the present, but for 2035, 65, and 2001. And for severity, we looked at a variety of different indicators in terms of the mission significance of the post. Some of them are more significant than others. The number of personnel and family members that might have to be evacuated. The more of those that you have to deal with in a disaster situation, the harder it is, as well as the replacement value of the assets in the facilities. And the vulnerability indicators that we looked at were of a variety of types, from the age of the facility, its condition, evacuation logistics, and those were the local ones. And then we also looked countrywide. The Department of State has travel advisories, as you all know, for different countries. And we looked at those as well as the others you see here in terms of access to potable water, the health sector, adequacy of power, which is really important as well, GDP, those kinds of things were how we established vulnerability of the portfolio. And then we just had a very simple risk calculation where you can see exposures and severity at a preliminary risk score. And then we use that vulnerability indicator as a multiplier. If it was higher, then that indicated greater vulnerability. If it was lower, then less. And from that, we were able to develop a risk score. And here you can see the entire portfolio of the Department of State posts distributed on a curve from very low risk to very high risk. And here you can see the examples of posts on the distribution of that curve. Notice London right there in the middle, just out of the area of pretty much no concern into the other area. And so I will say that this kind of a process needs to be iterative because things change, both the climate as well as the incident of natural hazards. So they will revisit this from time to time, more frequently than not. And here are the two posts, Tunisia or Tunis and San Salvador, where we actually did the on-site assessments. And for the on-site assessments, we also used a couple of military sources, the NAVFAC, Navy Handbook, as well as the Army Climate Resilience Handbook as references for what we did, and indeed the NAVFAC Handbook for the framework of its analysis. There's additional key terms that vary a little bit from the portfolio screening that we did down to the on-site assessments. And what we really were after was looking for how vulnerable the assets were and the infrastructure at the facilities of those critical assets. And it's a combination of exposure and sensitivity and the adaptive capacity, which I'll reiterate is the ability to adjust to negative effects of natural hazards, capture opportunities to increase resilience, decrease vulnerability, and then manage the consequences of the mission, but also importantly to learn from those kinds of circumstances and the kinds of things that go well, as well as the kinds of things that don't go so well when an organization responds to those emergencies. We did various things before we went on site. We looked at a lot of data that we asked for. We developed a questionnaire to send out to the local installations. We did interviews over the phone with the posts remotely. Everyone that you see here that we talked to, and we looked at site maps to look for topological changes and what was proximate to what, and so forth, as well as the local websites in both those countries about looking for what they had in terms of available climate data. In preparation to go on site, we looked at where we could find prior damage to structural assets, where utilities were located, and what was key in terms of the natural assets available, where runoff would occur, how stormwater was managed, and so forth. And then we drafted up a 5-day plan for what we were going to do on site. And with that plan, we used it as the means to guide who we talk to and when. Like every plan, once you get to the location, it has to change. And so we did that a lot because people weren't available when we, when we thought they would be, and so forth. So one of the things that we really learned was the importance of meeting with and talking with local authorities. And that goes for not just there, but everywhere that these kinds of studies, adaptation assessments are done, is understanding where the local authorities are at, what their response plans are, what their planning is, and how an organization like the folks who run this military base here, how they fit in with those plans and their interactions with those local authorities. And that's not something that's new. It's well known, particularly for military community and the communities that they live in and around, and that live around the bases. So after the on-site assessment, that's when we consolidated all the data, all the observations we made, the results of the interviews. We identified and recommended potential adaptation alternatives for the posts, conducted cost-benefit analysis of some of them. There are some that are projects that are appropriate for cost-benefit analysis. There are others that are more operational or managerial that don't require that. If it's to fix certain things or to conduct certain things like drills and so forth, that's not something one does a cost-benefit analysis on. And we also developed some recommendations for how the climate security and resilience program itself could be improved. Water scarcity was one of the things that we came up with, and actually limited options available for it. Now, that's not something that folks here in the UK have to worry about necessarily, but I suspect that there are many of you out there that work not only here, but will work in other places where that's more likely, or that you'll be sent there. And so one of the things that we identified is the potential use for atmospheric water generators in those kinds of places. And one of the interesting things we came up on was that they now have solar power that goes with those atmospheric water generators. And so consequently, they can be used without diesel, without gas, that kind of thing. Very handy where this kind of thing is wrong, is off the rails. Saltwater intrusion is another one, both from storm surge as well as the salination of watersheds and so forth, groundwater. Really important to be able to know if that's coming. That applies to utilities, communication equipment that's in tunnels or in piping that's underground, those horizontal assets that I mentioned, and making sure that you're not that saltwater isn't corroding those. These are the kinds of things that we saw as prospective adaptation alternatives, and there were cases where we saw earthquake damage in buildings and so forth, the replacement of temporary structures, particularly that were never built according to the standards of those days for earthquakes, let alone what the standards are now. And there were some management opportunities that we identified in terms of, like I mentioned, incorporating supply chain problems scenarios into drills. What do you do if something that's 300 miles away on a truck can't get to you because a river's flooded? And what alternatives do you need to have in place? What plan Bs do you need? Plan Cs even. And now I'm going to come to a Tyndall example. Let's see if this will work here. Ah, no, that's not what I want to do. How can I go back?
Okay. Previous.
I want to do this. Sorry. Can I turn up the audio? I know I should have ran this.
Images are pretty powerful. That.
Well, we're going to have to deal without audio, but as you could see, that was Tyndall Air Force Base during the hurricane when the roof was being blown off. And this was a final word that kind of prophetic at the end of that. There we go. So the reason that I want to talk about Tyndall is because not only is it an Air Force base, and I'm on an Air Force base right now, is that Tyndall can be considered a poster child. And this quote is from their website. And it's very easy to see this stuff because this is where I got it, from the Tyndall website. But the Air Force doctrine is 5 R's and of resiliency. And you might have seen those in the prior diagram that I had, of robustness, the redundancy, resourcefulness, response, and recovery. And interestingly enough, I had those in that diagram 3 years ago before this stuff came out. Here are the definitions, and it's really important for folks if they're going to get into this kind of an assessment or study, let alone set up a program, a resilience program at the facility, to recognize what these definitions are, and as well as, and these again can all be identified and found on the Tyndall website. The 5 R's encompass facility standards, including energy, utility, communications. In other words, everything that applies to design and construction on an Air Force base is what's going on at Tyndall as they develop the base of the future, as they say. And they're looking at defining performance expectations to withstand, respond to, and recover from threats using performance metrics. And looking at the building performance metrics should be, will continuously inform as they develop and focus on asset management. And they also see it as being further informed by the MDI. One of the examples that they give on the website that I've reproduced here is focusing on stormwater. And there are certain locations in the UK, there are many locations in the US, as well as elsewhere around the world, where this is important. And that's why I included it here. But you can see that there are a variety of nature-based infrastructure solutions available for that. And Tyndall is taking full advantage of this, given, of course, their experience with flooding. And they're also looking at being smart ready, which, of course, has to do with the capability to connect with the internet. And that has to do with the Internet of Things. There are also, of course, some cyber issues in terms of security for that, with that. And you can see it, that the last bullet, a resilient base thrives, survives, and bounces back from sudden shocks and stresses and over a period of time. So they're looking at their recovery plan and the analysis of alternatives. They're looking at master plan key objectives, and you can see what they look like here. Improving mission and organizational efficiencies by realigning mission sets to influence future development and to provide capacity for future growth. So what should an Air Force installation resilience program look like? I get asked this a lot, so that's what I put down here. Cross-functional team takes this on. You can't do it in one particular department, one area, and so forth. Identifying who can be hurt, what can fail, how it can affect the mission, and who's responsible for planning, responding, recovery. And I know that you folks here and the Air Force all over the world has a lot of that stuff already in place. You don't need to recreate anything. What you need to do if you're going to focus on resilience is put it together and then identify the parts that are missing. And so the assessment, if you chose to do that, would involve infrastructure, buildings, asset systems, entrance, egress, emergency response, hopefully the supply chain. These kinds of components go into it. And so that the resilience program would bring those principles into its operations and look at what needs to be made more robust, what needs to be have redundancy put to it, what sort of response and recovery that you'll have. And that way you won't be hiding your heads in the sand and miss that black swan event like we all did with COVID. Okay, let's see if hopefully this will work. If it doesn't, then no. Okay.
Go to the sound thing in the bottom right of the. Go down here.
That's it's not, I'm not getting it. Oh, down here.
Do you minimize this one?
This?
Yeah. Yeah. So that two down slightly. That one's close. Yeah.
This one? Okay.
That's
All right. I got you. Yeah. Sorry for the flashing through there like that. Now.
There's the one next to it.
Okay. Yeah, they're both maximums.
Yeah, they're next.
Okay. Now I think it'll work.
See,
Yeah.
quick here.
I think it has to do with the presentation settings. You have to
Yeah.
go to the.
Well, I can tell you what it's about. Unfortunately, you can't hear him talk. Might not be able to understand him if. So, yeah, sorry about that in terms of the audio, but what these gentlemen constructed was the only building that survived Hurricane Michael on the coast that blew away Tyndall Air Force Base. And they did it by exceeding the local hurricane standards on the building. Instead of it just being constructed to withstand 120 mile an hour winds, they constructed it to withstand 240, 250. And that's why it survived. And they used steel reinforced concrete throughout and so forth. And of course, Tyndall has taken a lot of this to heart in their reconstruction. So that's the end of my presentation, and thank you folks for having me here and letting me visit with you about this, and just thank you very much.
Yeah, brilliant. Yeah, thank you very much. Mate. Great. So, it's all right with you. Have some time for any questions?
Sure. Yeah.
So, if you're dialing in and have a question, please raise your hand, and I'll come to you and let you introduce yourself and ask your question. Similarly, anyone in the room, Matt, get us started up.
Matthew Scribner, AFI MSc PM here on RAF Mildenhall. Mick, what kind of natural hazards or climate hazards were there for London, England?
There was flood, as well as storm surge on the Thames They put in gates to allow water up and allow water down to protect it from storm surge from the coast. But that was why it was in the middle of the patch, if you will, middle of the portfolio in terms of risk. There was nothing dramatic about it, but it had to do with wind and water. No earthquake, fortunately.
One from me, you mentioned quite near the start, there was a big list of natural hazards. I was wondering if there are any of those in particular you think are really going to be rising in prominence over the sort of rest of the century.
Well, sure. What we've seen in the last several weeks in terms of heat and along with that water stress, as well as I think that they're all really increasing is what we're seeing. The ones that are most dramatic and right now are heat, fires, water stress, those kinds of things. But wind is not lessening either. The storms here in Germany this past year, or over in Germany in the past year, with the tornadoes that they've had. When I first started presenting on the climate change work back in the early teens, I did some presentations over here, and there were people in the audience who would say, "There's no tornadoes in Europe." And I said, "Well, that's not what the data says." And then finally, I was able to come up with some on picture or on from the press, and was able to show those. But those kinds of violent storms have increased over time. So wind, flooding is increasing, and you see that in the UK in terms of the pluvial flooding from rainstorms, really affecting a lot of places in low areas, nearby rivers, but also over broad sections of lower ground.
Great, thanks. Yeah, any other questions, either from the room or online?
Are you seeing a change in opinion on how they fund projects as you're moving through? Because obviously we fund to do enough at the moment, and how long has it taken to sort of push that through from your experience to fund to do future proofing?
The funding has increased dramatically. I was at the DoD climate workshop in St. Louis 2 weeks ago, and the amount of funds that they were talking about available there just for projects in the US was immense. We've just seen a lot of it. A lot of it has to do with partnerships with communities. Now, I don't know how that extends over here into the US Air Force and the UK, but at least in the US and what's coming out of the DoD and out of Congress is dramatic increases in it. It's finally gotten to the point where it can't be ignored, I think. And obviously, there's billions of dollars going into Tyndall.
Thanks. We've got a question from the call from Carl Sayer. So yeah, Carl, thanks, and over to you.
Thanks, Tom. Thank you, Mick. That's been really a good presentation. It's just a query, really. Is there kind of like a DoD standard, like some of the things we often see are like UFCs and Unified Facilities Criteria and standards like that? Is there any standards that would relate to kind of like UK DoD construction projects that would kind of support us in this kind of effort?
Well, not being an engineer in the UK like there are folks around this table, I can't speak to that, but I also can't imagine that there are not construction standards that either have increased or are being re-examined. At least I would think that that's possible.
You mentioned that a NAVFAC and USACE codes you've referenced in the Department of State work.
Yes, there were. Well, those were handbooks, but there are. The Department of State uses a variety of different codes those at the local level around that are country specific where they're at, as well as their own, and they continue to reassess the ones that they have to make them more applicable. That's what they're using the data that the compliance or the climate security and resilience program is developing is to help them recognize where they need to increase the construction standards and the standards when they renovate at a post.
Great. Yeah, thank you.
Yeah,
Thank you.
Thank you very much.
You're welcome. Thanks for tuning in and listening.
And then we've also got a question from David Green. So yeah, over to you, David.
Hi, thanks, Tom, and thanks, Michael, for a very interesting talk. I'm a civil engineer based at RAF Lakenheath, working on the same project as Tom. Obviously, in engineering calculations over the years, particularly on a lot of the software-based systems, we have a factor of safety added now for climate change. As a result of your studies, just be interested to know, because it's not often been discussed, is the factor of climate change increasing exponentially each year, or is it a gradual curve, or are you finding that the more that climate change affects, the greater year-on-year effect it has, almost like a compound effect, if that makes sense?
Mm-hmm. It makes sense. I think it's the latter, because obviously the facilities age year by year, and the funding that's applied to them tends to get applied in one tranche, and a project is done, there's renovation or construction, and then that's it for some period of time. So I think that as they age, they become more vulnerable. And when you compound that with the increasing severity of the severe weather effects against them, whether it's wind or whether it's heat that increases, you have a compounding effect. So I think it's the latter, and I think it will only grow worse.
Great, thank you.
Okay, thank you very much indeed for that. Thank you.
Sure. Thank you.
So yeah, any other questions either in the room or? Great. Well, in that case, leaves it to me to say thank you very much, Mick, again for coming to present to us, and yeah, for a really engaging presentation. And then looking forwards, we're for the UK post of SAME, we're going to have a break through August for the vacation period, but then keep an eye on your calendars for an event coming up in September that will be looking at sustainability in construction, and yeah, we'll keep you all updated with future events through the usual channels. But yeah, thank you all very much for your time. We had several times more people dialing in as well, joining us. And yeah, hope you'll all join me once more in thanking Mick.
You're welcome. And for any of the SAME board members out there who may be listening in, Tom has been a wonderful host and in helping me with the logistics and giving me a tour of downtown Cambridge yesterday and getting me out here to the site. So you're being very, very well served by his highly professional participation in your organization. And thank you for having me and having Tom help me.
Thanks, everyone.